So hello everyone. In this video, I will be going through the MA 162 exam 1 for fall 2021. So going on the first question, we're asked to find the radius of a sphere given a point and the center of the sphere. So here, there's really two ways to think about this. So if we draw a sphere here, and we'll mark the center with a red dot. So if there is a point, let's say somewhere right here, then the distance between this point on the sphere and the center should be the radius. Right, so in this case, since we have a point and the center, we can say that the distance, using distance formula, between these 2 points, so distance between 2 points, using the point as the first and then the center as the second point. So in this case, I want to keep the order the same, so 0 minus 1 squared plus -3 minus 1 squared. And all that should be the distance between the points, and that should be the radius. So that'll be the square root of 1 squared, which is 1, plus 1 squared, -1 squared, which is 1, plus -4 squared, which is 16. So it's root 18. You can take a 9 out of that, so it'd be 3 root 2. In the other case, you can think about this using the sphere equation. So in that case, it would be what? X minus 1 squared plus y minus 1 squared plus z minus 1 squared equal to r squared. Right, so this is from the center here. So I'm just plugging in, it would be what? X minus x0, y minus y0, and z minus z0. And that, I'm just plugging the center point into x0, y0, and z0. And then there's a r squared on the other side. So x, y, z here can be any point on the sphere. So I can just plug this point in. So, alright, 2 minus 1 squared plus 0 minus 1 squared plus -3 minus 1 squared, get r squared. Square root both sides. And you'll see that it's exactly the same thing as we did up here. Right? And we result in the same result. But it's two different ways to think of this. If you this way is more of a plug it into formula, right? If you remember the formula, you can plug it in and you can solve for the unknown, which is r in this case. Or in another case, you can think about it as a distance, right? You can visually think about it and know that it's just a distance between the 2 points and use distance formula, and that will work too. So going back, got 3 root 2, which would be e, which would be the right answer. So for the second question, we are to determine which of the following vectors are not a unit vector. So first, let's see, remind ourselves the definition of a unit vector. So a unit vector, in this case, should have a length of 1. Length equal to 1. So we do the distance formula of that vector, that should be 1. So let's just go through each of them here and see if their length is 1. So here, we have 0 squared plus 4/5 squared plus 3/5 squared, which equals to will be 16 over 25 plus 9 over 25, which is 25 over 25, which equal to 1. So this is indeed a unit vector. Going through, same thing with B. 2/7 squared negative 3/7 squared. Then have 49 plus 9 over 49 plus 36 over 49. So what is 13? 4 plus 9, 13 plus 36. That would be 49. So root 49 over 49 is indeed 1 again. C is just the j vector, which in this case is a unit vector itself. So that is a unit vector. And then I, j, k here are all unit vectors, so we're really concerned with just the multiplier in front. So in this case, this will equal to 1 over root 3, 1 over root 3, 1 over root 3 as a vector. And here, doing distance formula, right, so the length of that will equal to 1 over root 3 squared times 3, basically, right? So it'd be 1 over root 3 plus 1 over root 3 squared plus 1 over root 3 squared, which is 3 of them, which equals 2. So the square will be 1 squared over root 3 squared will be 1/3 times 3 will equal to 1. And this is another unit vector. E, same thing. We do cosine pi over 10 squared plus 0 squared, which I will just ignore, sine over pi, sine of pi over 10 squared. And here is the identity that you will need to know, that I'll write it over here in red. So cosine of any angle, the square of cosine of any angle plus the square of sine of any angle is 1. It doesn't matter how big the angle is, how small the angle is, this identity will hold true for all angles. Just going back here, so it doesn't matter if it's a pi over 10, pi over 2, pi or 0, right? So we have cosine square of some angle plus sine square of some angle, so that just equal to 1. So root 1 is 1, so that is a unit vector. And going down here, so by the process of elimination, we know that f is the answer, but I will still go through it. So we have 1/3 squared plus 1/3 squared plus 1/3 squared. That would be what, 3 times 1/9, which in this case would be root 1 over 3. So this does not equal to 1. So this is not a unit vector. So although it has, 3 of 1/3, you think that's going to be a unit vector because it adds up to 1/3. It adds up to 1. But if you really do the distance formula here, you will see that it ends up not being equal to 1, and that will be our answer. So F. So for question 3, we're given 2 vectors, and we have defined a projection of those vectors of a vector W onto vector V. So first, let's write down the projection equation. That's the wrong button. Right, the projection equation of, let's say, a vector A and B. projection of B onto A would just be the dot product of the vectors over the length of vector A times the unit vector which is the vector divided by the length. So that will be important. So basically what we just do here is just plug it in. So vector V for vector A and vector W for vector B. Right, so since we need to find the length of vector V for twice, I'll just do it first. So square root of -1 squared plus -2 squared, which is square root of 5. And then, so now we can do it. So the projection will equal to V dot W, which is -1 times 2 plus -2 times 3. All that over the length of A, which is root 5 times the vector V over root 5. Here, root 5 makes 5, and this is -2 minus 6. We'll have -8 over 5 of -1, -2. Just multiply this in. So we have, actually that should be positive. And that will be our projection. So look at our answer choices here. It'll be choice B. And let's see. So for question 3, B will be the correct answer. So for question number 4, we're given 3 points with one of them having a variable. And for these 3 points, it forms a triangle with a known area. So first of all, I always use a cross product for this. So let's just draw a graph. Let's say this is 0, 0, 0, or let's just say there's 3 points for a triangle. They form a triangle, and then we have a vector here from point, let's say that's point A, B, and C. Right, so we have 2 vectors, and we can call them, Q and P. Right, so we're able to, if you will remember, that if I cross Q and P, that will actually be the area of a parallelogram. And I'll show you why. So if we have the angle between S theta, right, let's complete the triangle here. And still the cross, that should be a cross product. So the cross product between these two will be the length of Q times the length of P times the cosine, sine of the angle, right? The angle theta. And if we look at here, if we draw just a perpendicular line down here to P, you can see that this, let's just call it H, as the height for this triangle. If you can look at the relationship between H, theta, and Q, you realize that Q times sine theta will be H. As we've looked at this right triangle here, Q would be hypotenuse, H would be the opposite. So, um, uh, so we have sine theta. It would be opposite over hypotenuse. So if we times the length of Q on both sides, that should be a Q. We cross that out and we get H is Q times sine theta. And in this sense, we can replace Q, length of Q, and sine theta with H. Right? H times length of P. And that would be the area for a parallelogram like this, as the area of parallelogram would be the base with the P times the height. But we want a triangle, so we can just take half of that. So half of the cross product here would be the area given here. So now we can go back. Let's say this is 0, 0, 0 for point A. This is 1, 1, 1. And this would be A75. And it's pretty nice that it's given to point 0, 0, 0. So the vectors Q, then be A75. P would be 1, 1, 1. When we cross this, we have 7 minus 5, which is 2. We have A minus 5, but the negative that, then A minus 7. So here, the length of this vector will be the area of the parallelogram. And if we do that should be a minus, right? Plus a squared minus 14a is 47, 49. So here, this would be 2a squared minus 24a 49. Right? No, it should be 78. Yeah. 78. And all this divided by 2 will equal to the area, which is root 6 over 2. So here, since we have the 2, we can cancel out, and we can square both sides to cancel out the root 2, the square root. So we have 2a squared minus 24a plus 78 equal to 6. Divide 2 on both sides. Move the 3 over. Then we have a is Let's see. Nine and 4 doesn't work. So A will equal to 6. Will be our final solution. Let's see, for 4, A will be correct. So for question 5, we are given the length of the cross product between two vectors v and w, and the tangent theta is √3, where theta is the angle in between, and we're to find the dot product. So this question is actually a little tricky. It can be done really easily, but you have to know the little trick. So if we just look at what this cross product means, right? So we have the length of this cross product between v and w, which is the length of w times the length of v times the sine of theta, where theta is the angle between, right? And then, you know, when you think about this, you might think, I need to get the length of w and the length of v, and somehow get the theta, right? So I can calculate, so the final step would be something like v dot w, we go to length of v times length of w times cosine theta. But when we write this out, you realize this part is the same as this part, right? If I highlight this in red. So really, you don't really need that. You define the individual vectors, right? If you see this as x, right, you don't need to find x to find the dot product, and I'll show you why. So as for just remind ourselves that tangent of any angle is sine of that angle divided by cosine of that angle. And so here we can see that really the difference between the cross product and the dot product is the angle with the multiplier in the back, right? Well, for cross is sine, for dot is cosine. So we've given this to equal to 3, and we're given the tangent equal to √3. So there's then a very simple way of converting this sine to the cosine. So you can just get the dot product straight away, right? So if we divide this part, let's just say I have this part over here. So if we divide, so length of v times length of w times sine theta. If we divide this by sine, right, 1 over sine times cosine theta, then the sines cross out, and then we're left with just cosine theta, and magically that is what we want, right? That is the dot product equation. So and then think about, well, what is cosine over sine that we can multiply, right? That is simply just the reciprocal of tangent, right? So if we multiply the cross product here, by 1 over tangent, which in this case would be, right, you just flip it around, cosine over sine, right? And then we're able to just cross out the sine and left with cosine. And so that's the strategy we're going with, right? So we can do the dot product here would just be equal to 3, which is the length of the cross product, divided by tangent theta, which is just root 3. So that equals 3 root 3 times top to bottom by root 3, and you get 3 root 3 over 3, which is root 3. In this case, would be C, and that would be the answer. For question 6, we're given 3 equations, and we're trying to find the area bounded by these 3 curves. So for these questions, I do recommend first drawing them out and getting a sense of where they are and what it is mean by bounded by them. So a simple XY plot will do. That should be a straight line. So we have, first of all, y to e of x, something like that, where it crosses at y equal to 1 and x to 0. And e to the negative x should be just the other way, like so. Finally, we're bounded by x equal to 1. So let's say this is 1. So now it's pretty clear that we are dealing with this area right here. So then, now we can see that it's bounded between x between 0 and 1, and on top we have e equal to x, and on bottom we have e equal to negative x. So then, we just write a simple integral. So top minus bottom, e to the x minus e to the negative x. And of course dx, we're integrating over x here, and the bounds would be the lower bound bounded by 0, and the upper bound would be 1. So now we solve this integral. So e to the x, it doesn't change, right? So e to the x stays e to the x, and negative e to the negative x, since we have chain rule of this negative here, that comes down, and we actually have positive e to the negative x, and that will all be bounded between 0 and 1. So then we just plug 0 and 1 in, right? So we have e to the 1, which would be e plus e to the negative 1, and this would be the minus e to the 0 and minus e to the negative 0, which is 0. And in this case, it would be e plus 1 over e minus 1 minus 1. Anything to the 0 should be 1, right? But if you look at the answer here, none of them really match what we have here. And we can see that it really only have one term or 2 terms. So what we do here is try to change our answers and see if we match one of the forms here. So for here, I would just recommend, since this fraction here is the only fraction, so I will just make sure everything is in the same fraction. So I'll make everything over e. So in this case, it would be e squared over e, which is e. The second term doesn't change, minus e over e, which is 1. And 2 of them, so I would just combine them and say it's 2e over 1. And now I can combine all of them, right? So I will have the greatest power goes first, e squared minus 2e plus 1. And now, if you got a sharp eyes, you will realize this is a perfect square on top. So this actually just equals to e minus 1 squared. And all of that is over e. And we can see that that's actually our answer D here. And if we go back, answer D for 6 would be the right answer. Thank you for watching this video. The past exam archive and all the videos I did related to this exam will be linked in the description below. Please check them out if you're interested. Thank you.